Alrighty, let's see what we got today. Maximum total subarray value, part 1. You're given integer array nums of length n and integer k. You need to choose exactly k non-empty subarrays from nums at L to R of nums. Subarrays may overlap, and the exact same subarray can be chosen more than once. Interesting. The value of the subarray is defined as the maximum of the value minus the minimum of the values in that subarray. The total value is the sum of the values of all chosen subarrays, which are in the maximum possible total value you can achieve. So I guess you probably, assuming, can these values be negative? These values cannot be negative. So assume that you'd want to always use all k subarrays, even if they're identical. Alright, so 2 is the number of non-empty subarrays. I think you probably want to use 1, 3. So that's a difference of 2 times 2 is 4. I wonder when you'd ever use something that's not the same. Okay, so here there's 3. I think you probably do 5, 1. So this is 4 times 3. Subarrays may overlap in the exact same, can be chosen more than once. The exact same subarray, L to R. Why are they choosing 3 different ones if they can just choose the same ones? What? You need to choose exactly k non-empty subarrays. Subarrays may overlap, and the exact same can be chosen more than once. So when would you ever not choose the same? Oh my lord, this is really weird. Like, it seems the only thing that I feel like this must be a typo, no? The only reason why this would be anything that isn't difficult would be if it's not if this thing is cannot. Otherwise, I think you just choose the exact same, right? You say like the biggest difference was going to be the max of the array minus the minimum of the array. Like you're choosing basically the whole array. Okay, let's see why it wouldn't just be this. I don't understand. There has to be. What the fuck? Okay. What? What is going on? Okay, I guess maybe just not having that other variable probably is going to make it slightly faster. But what is going on with this problem? Like, why is it like this? I really don't understand. Like, obvious, I mean, if there is a biggest difference between the max and the min, that is strictly positive, because all the values in here are positive, so there's no way that the max and the min can have a negative difference. Then you just use that same subarray k times. I guess, okay, this is part 1. So I assume part 2 is maybe has negative values, maybe can not choose the same subarray, in which case it makes sense a little bit. I don't understand. I really do not understand what is going on with this problem, in the sense that it seems trivially kind of easy to compute since all values are positive, so therefore the difference is always positive. Difference between high and low, or max and min values, is always positive. And being able to choose the exact same subarray would just mean you would use all k subarrays on anything, including the whole array as a subarray that has that max and minus min value, max and min values. I assume that the follow-up, like part 2, might have a better or harder set of constraints about the values in the array, or the ability to choose the exact same subarray. Anyways, time complexity is going to be O of 1. No, sorry, it's over n. To find the maximum of an array, it's an O of n computation. Yeah, that's sad that I had to think about that, since you need to find the max and min values in the array, which requires the single pass through, but very fast, obviously. Space complexity is going to be O1, since no extra space is needed. Okay.